Hey YouTube, welcome to the next episode of differentiation. We're on episode 8. So last lesson we discussed what is a stationary point and how do we define the nature of them so they could either be maximum minimums or inflections. Now we did summarize this point, I'll recap it. So at a stationary point, if you found the stationary point at x equals a, if you find the second derivative and sub in that value, if it's positive, you have a local minimum. If you sub in that value of a and you get a negative number, then we have a maximum. But if we get 0, it could be any type of point. So we need to resort to checking gradients on either side of that stationary point. I'm going to show a couple of examples where that's the case. Now let's just practice the first 2 bullet points with this question. It says find the coordinates of the stationary points on this curve and determine whether the stationary points are max, minimum, or inflection. So the first thing we're going to do is we take our function. It's a cubic here. We're going to have to differentiate first to locate the stationary points. So f dash x. So we differentiate that, we get 6x squared plus 6x minus 12. Then we make that equal 0. We can divide through by 6. Then we can factorize. So we have x plus 2, x minus 1. So our solutions for where the stationary points are, x is minus 2 and x is 1. Now since they want the coordinates, we can use our calculator to do this really quickly. Now the best way to do these is to store our values. So minus 2, store it as a. Then we'll sub into f of x. So 2a cubed plus 3a squared minus 12a plus 5. So we get 25 there. Now the quick way to subbing in 1 is we press this calc button. So we press calc, press 1 equals, and press equals again, and then we've subbed in 1. So we have when x is minus 2, y is 25, and here y is minus 2. So there's our coordinates. But now we need to determine the nature, so we need to differentiate again. Now remember, do not differentiate the simplified version. That was only for solving. We need to differentiate our original. So 6x squared becomes 12x, 6x becomes 6. And then we need to sub in our x values to determine the nature. So we're going to sub in minus 2. 12 times minus 2 is minus 24 plus 6 is minus 18, which is negative. Therefore, we have a maximum. When we sub in 1, we get 12 times 1 plus 6 is 18, which is bigger than 0, which is a minimum. So to sketch this for part B, hence sketch the curve, all we need to know really based on part A is where the turning points are. So we have x is minus 2 and y is 25, so say up here. So minus 2 and 25. And then we have x is 1, y is minus 2. So say somewhere here maybe. 1 minus 2. It's not to scale. But another thing we know is where it crosses the y-axis because of that plus 5. So it's going to cross somewhere here maybe at 5. So our cubic will look something like this. Yeah, because remember, we proved that at minus 225, it was a maximum, and the other one was a minimum. So this is just a very quick sketch as to what that cubic looks like. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Find the coordinates of the stationary point on this curve and find its nature. So we have f of x is x cubed plus 3x squared plus 3x. So differentiate once. So we get 3x squared plus 6x plus 3, make equal to 0, divide through by 3. Factorize, we get x plus 1 on both. So there's only one stationary point here at minus 1. Now let's take that and let's substitute it into our function. So minus 1, store it as a. So we're going to get a cubed plus 3a squared plus 3a. So the y value is minus 1 as well. Now we need to define its nature, so we differentiate twice. So remember, we differentiate the non-simplified version will be 6x plus 6. Now when we sub in the x value here, you notice 6 times minus 1 plus 6 is 0. Now this does not mean it's an inflection point. It could be any type of point. So remember what we do. Once we have the second derivative is 0, we need to find the gradient on either side of this point x. So here we have a 0 second derivative. So we need to check the gradient on either side of minus 1. So I'll change color just to change the situation. We're going to take f dash. We're going to find an x coordinate on either side. Let's do minus 2 and let's do 0. Now, subbing in 0 is actually easy. I'll do the second one. You're just going to be left with 3. But let's sub in minus 2 into this. So let's do minus 2 store is a. So we have 3a squared plus 6a plus 3. So we also get 3. Now, say you did it this way. If you press the calc button, you could change this store to 0 and then do it that way. But since both of these gradients are positive, we have an inflection point. Yeah, so because we have both positive gradients on either side, we have an inflection point here at minus 1, minus 1. Find the coordinates of the stationary point on this curve now. So if we take f of x to be x to the power of 4 minus 1, when we differentiate once, we get a nice easy 4x cubed. And we make that equal to 0, divide by 4 and cube root, we just get x is 0. Now, when you sub in x is 0, you just get minus 1. So our coordinate of the stationary point is 0, minus 1. Now let's define what type of stationary point that is. And when we differentiate twice, we get 12x squared. And when we sub in x is 0, you get 12 times 0 squared is 0. So again, could be anything. Could be a maximum, minimum, or an inflection point. So let's resort to checking the gradients on either side of our point x is 0. So I think the good ones to choose would be minus 1 and 1. So let's check f dash 1 and f dash minus 1. Now remember we're subbing into here. So 4 times 1 cubed is 4. So it has a positive gradient at 1. Then at minus 1 you have 4 times minus 1 cubed, which is minus 4. Which is less than 0. So how does it look? At x is 0, we have a 0 gradient. At x is 1, we have a positive gradient. And x is minus 1, we have a negative gradient. So we clearly have a minimum point here. So you can see, not always when the second derivative is 0 do you have an inflection point. So therefore, we have a minimum point at 0, minus 1, and that's our solution. So in this, guys, I've just shown you how we utilize second derivatives and how we can discover whether something is a maximum or minimum. I've also shown you how we can sketch graphs really easily using this information. So stay tuned for the next episode where I'm going to look at optimization, which is probably the hardest part of differentiation in year 12 anyway. So I look forward to it. If you learned something, guys, please hit the like button and subscribe if you want more maths content. I look forward to seeing you in the next video. Peace.